Yeah. Okay, now I'm recording the session. Lab 4, let me wait and see. The deadline is this evening, so when I receive your Lab 4, probably we can discuss it. I have some comments. For the students who did not submit Lab 4 again, make sure you explain. When they ask you to explain, try to explain the observation. Why did you get this? So I corrected one or two, and they said a lot of students are explain or basically describing what they see without explaining why it's happening. Okay, so try to add more explanations. By the way, I need to discuss something very important. If I believe you need to do some modification on the lab report, I'm writing a very clear note for you, and I'm giving you a grade of 50%. 50% is not your grade. I don't know, maybe it happened to 2 students. I don't know if they are here with us. 50% means please come back to me, email me, submit again, and let me grade you again. The 50% is only for you to be able to read my comment, okay? I want the 50% to be shocking in a way because I need your attention, but I don't want you to be frustrated because this is not your grade, okay? Do you hate this? I'm waiting for somebody to respond. Yeah, all right, Fadil. Fadil, it happened to you, no? Or it's not you, Mbala, it happened to you. Yes, so Fadil, this is not your grade, okay? Don't be frustrated. I'm sure you deserve a much better grade. Yeah, lab 3. This is only to grab your attention because I need to talk to you, okay? And I would say this is incomplete grade. I'm gonna grade you again. Okay, Fadil? Fair enough, because one student in freshman was really upset. And he is a very smart student, very serious student. So in no way this is not your grade, okay? This is only a way to communicate with you. I can simply email you, I know, but I want you to read the comments on the Blackboard. All right, I think we're ready to start lab 5, RC circuits. As I was saying to your friends, this is one of my favorite labs. Let me tell you why. Because when I was back in high school, I studied a lot of RC circuits. I know charging happens, discharging happens, but I never knew I can simply observe this through a voltmeter. And you know, you can have a voltmeter at home. So it's like a homemade experiment. I know we can use a sensor through Data Studio and observe those beautiful graphs, but we decided to keep it homemade for you to have a feel of what's happening on your tiny circuits, okay? RC circuits, I need somebody to speak up to give me a definition. What are RC circuits? Anyone? Shaibel, Francesca, Ramza, Joanna, Rawan, Maria, Michelle, James, Nagam, anyone? What are RC circuits? So, yeah. So you have a resistor and a capacitor connected how? Okay. Do you have a battery or you don't have to have a battery? So you said, yeah, so, okay, so you said you need a resistor, right? Resistor, you need a capacitor, and maybe a battery, right? Okay, let's keep this, make it a bit smaller so we can keep it. Okay, so these actually good. All right, maybe zoom in a bit so you can see it. All right, so you can see a circuit in which charging and discharging happens at the same time. I need somebody to speak up to tell me why is circuit B charging and why is another circuit B is discharging. So anyone? Let me call them circuit 1 and circuit 2. Okay, so every time you have a battery, supposedly you're charging your capacitor, and whenever you don't have a battery, you're discharging the capacitor. Can you tell me how long does it take for the capacitor to be fully charged or fully discharged? Depends on what? What parameters? Anyone? All right. Okay, so you're saying that you need 5 tau for the process to finish, approximately 5 tau because it's an asymptotic behavior. And you're saying that the tau is R times C. So it depends on R only and C only, which means it does not depend on the battery at all. What if I remove my battery and use a stronger battery with a bigger EMF? Don't you believe your capacitor will charge faster? Yes? Okay, so yes, yeah. Beautiful, Ryan, beautiful. So even if the battery is so strong and powerful, this will not affect the time. And you can see it. Maria just gave us the time constant of the circuit. It will not affect the time. It will take exactly the same time. It's only that it will reach a higher voltage. That's all right? So I need somebody to explain what happens when the switch is on A and what happens when the switch is on B. So this is like a variable switch. It can click to A or click to B. Anyone? Yeah, so look at the first circuit. You have a battery, you have a resistor, you have a capacitor connected as such, and you have a switch in here. Probably remove what I just drew. Okay, so you have a switch in here. You can put the switch either on A or on B or in the middle. In the middle, nothing happens because everything is switched off. What happens when you put the switch at A? Yeah, that's true, Maria, and I can read Rawan and Fadl as well. So when I put the switch on A, I will have circuit 1. And when I put the switch on B, I can see circuit 2. Okay, you see it? So circuit 1 and 2 are basically the original circuit switched at A and B at the same time. I love this combination. Where am I? I'm here. I love this combination. Unfortunately, we're not gonna do this in the lab. In the lab, we're gonna do circuit 1 alone. When we're done taking measurements, we're gonna do circuit 2 alone because it's easier experimentally. All right, before moving to the experimental setup, I would want to discuss a little bit the charging curves. So I need people, someone to discuss what's happening. So basically, if you look at the circuit, give me a second. Okay. Yeah, this circuit, charging or discharging, and how do you know? Very simple, actually. This is grade 11 material or grade 12. So how do you know if this circuit will give you a charging process or a discharging process? Anyone? Okay, you can see the current direction. Yeah. How does it help you? Maria is saying charging simply because you have a battery, you know, by simply somebody said uh, a few minutes ago, maybe Ryan, I don't remember, since you have a battery, definitely this is a charging process, okay? And you can see it's a charging RC circuit. Now, you can see two graphs. One is for the charge or basically the voltage, because by the way, U and Q are proportional. So U is the potential difference across the plates, and Q is the charge on one of the plates. They're proportional because Q is U times C. So whatever the shape of the graph for Q will be the same as the shape of the graph for U. Anybody who can explain the Q versus time graph? Why does it look like this? The Q versus time graph for the charging. Why does it look like this? Anyone? James, Francesca, I saw Francesca signing in. So again, for the newcomers, we're discussing the charging process. Q, is it increasing or decreasing? How is it behaving? In a linear way, in an exponential way? What is the maximum? This is what I want to discuss. Anyone? Probably you can't hear me because you're not responding. Of course, I want you to answer, Ryan. Go ahead. Okay, so this is reaching E of the battery. Yeah, the U is equal to E. Probably write it. Do I have a thin pen? Because I zoomed in a lot. So this is where E is equal to U, or U is equal to E. This is where you reach the voltage of the battery. And you're saying, is it a linear increase or an exponential increase? You just said probably exponential increase. Yeah. Can you discuss tau a bit? Anyone? What does tau represent? All right, Anthony, no problem. Yes, Ramza. Yeah, 63%. Yeah, so it's basically 63.2%. So you take your maximum, which is 5. What is the 63.2% of 5? Apparently here they're stating it's just above 3, maybe 3.2, is it? Or 3.1, I don't know. You can simply do 5 times 0.632. You get the value and you go down to find the time. It's very close to 0.5 for this graph, seconds, okay? So tau is the time needed to reach the 63%. In the lab, we're gonna know what is the maximum voltage using a voltmeter on the battery directly, and then do the calculation, 63% of the maximum voltage, and wait to reach it. It means the 63% of the maximum voltage. We have a stopwatch to use. A lot of students use their smartphones, so they end up with 2 decimals, which means 3 or 4 sigfigs, depending on the order of magnitude of the time measured. I will be using this digital stopwatch of the lab, which has exactly the same precision, so to measure the time. I need somebody to discuss how come the current versus time is a decreasing curve. Anyone? So I'm still in the charging process, but the current is decreasing exponentially. So why do you think so? Anyone? Nagam, Sherbel, Joanna, Lisa, Michelle, Anthony. Ryan, you can talk. It's okay. You don't have to give time for everybody else to talk. Just unmute and talk. Yes, why is the current decreasing? Yeah. Yeah. Yeah, Ramza is saying because the voltage is decreasing. Listen, Ramza, the voltage here is increasing with time. All right, because you're filling up your capacitor, like you're giving the capacitor a certain potential difference between the plates. It was initially neutral and the voltage was 0, and then it's like any bottle. When you fill in the bottle at the beginning, the flow is so fast, the flow of current, and then whenever it's full, it will be hard for you to squeeze in more water particles or more charges, you know, inside. This is where the current will go to 0. So the current will go to 0 through the charging process and to 0 through the discharging process as well. I don't remember, actually, I don't have one for the discharging. I don't have a slide for the discharging process. I want us to do it together. This is the point of me not including it in our slide. By the way, it's important. Thank you, Ryan, for giving me this insight. Oops, I zoomed in a lot. Just a second. This is due to the recording. The motion of my slide is a little bit, yeah. So the current is V over R. This is a simple Ohm's law to tell you the maximum current is maximum voltage reached divided by the total resistance in my circuit, which is R in this case. Before I move on to the discharge, I need somebody to speak up a bit about tau. What is tau about for this curve? which is a decreasing exponentially curve. Anyone? Probably I don't want to talk about tau in the current. Just leave tau for the voltage and the charge. I don't want to end up confusing you. I'm going to move to another slide. This other slide actually discusses, and let me zoom out a bit, the discharging curve. Okay, so I need somebody to help me. So I'm going to switch this to discharging. What do you think I can do to my circuit for it to become a discharging circuit? Any modification I should do? I need your input, my dear friends. Remove battery. Thank you, Fadil. I'm gonna remove the battery. What else? By removing the battery, I will have an open circuit. You know, by open circuit meaning, yeah, like you have an open, the current will not flow. So discharge is not happening yet. I should do one extra step for the discharge to happen. So you'll have some emptiness at the position of the, close the circuit, Maria, thank you so much. So use a wire to close the circuit. In this case, what happens? The capacitor is fully charged, I assume. This is the positive plate, this is the negative plate. How do I know? Because I can look at my initial battery. Now it will discharge through the resistor. And the current now is opposite to the initial current of the charging, because the charging happens in one direction, the discharge happens in the opposite direction, because you're filling in your capacitor and then emptying your capacitor. You believe that eventually the charge will go. How come the energy in the capacitor will leave? Where does it go? Anybody? You know, you have some electric energy stored in the capacitor, and you know the energy is never destroyed. It has to go somewhere. Where does it go? You know, when I eat, I get the food, the calories I use to move my muscles. So energy, thermal. Thank you, Maria, so much. How thermal? The resistor will heat up and it will send some heat energy into the environment, okay? This heat can be used or maybe cannot be used. Maybe you can heat your coffee or food or anything. So all this energy stored, electrical energy stored in the capacitor will go as heat. Now I need to change my graphs a bit. The charge will decrease because of the discharging that is happening. So I'm gonna start from the same maximum and go down, okay? It's an exponential decrease, and I need to discuss the fact that 37% of the maximum value will give me tau, okay? As a quick reminder from Maria, 5 tau will give me the full process. Now for the current, it will look exactly the same, but it has to be negative. So I'm gonna write negative 1.2, negative 1, negative 0.8, negative 0.6. Why negative? Because the positive direction was initially clockwise, and now the current for the discharge is counterclockwise. So probably make it clear for the students who are not with us. Make sure the current, and I'm gonna change the font in a moment, the current is negative during the discharging process, okay? And again, process. And again, there's nothing in physics called negative. Negative means opposite direction. In my case, the current was initially clockwise, and it happens to be counterclockwise during the discharge. Okay, so maybe move this a bit. You think I can move it a bit? All right. So how do I define tau? For the charging process, I take the maximum, multiply by 0.63%, find on the graph and find tau. For the discharging process, I look for 37% of Umax or Qmax and find tau. All right? Let me discuss tau a bit. So time constant of the circuit. Maria already told us that tau can be calculated using two methods. Can you remember what are the two methods that we actually use to find tau? I can name 3 methods, and probably I want to name them like method 1 and method 2 and method 3. Yeah, I need people to speak up to give me 3 different methods to find tau. Anyone? Listen, this session is interactive, which means you have to build in your theoretical background, especially that most of all this is high school material. I know that probably you're not involved in the live sessions, especially that the session is recorded, but I really want you, and since you guys, you know, we're not taking attendance, since you have the choice to be absent, being online without talking to us would mean nothing, okay? It's not like you're, but I do totally respect the fact that probably you cannot unmute yourself due to many reasons, but I really need your input, okay? And I believe you can give a lot on those, especially that this is high school material. So my question again is, I need 3 different methods to find tau. By the way, the objective of this lab, one of the objectives, like the main objective, is to measure tau. 3 different methods to find tau. Already one of the methods was given by Maria. Maybe Maria can remind us. How do we find tau? Yeah. Yeah. Yeah, I totally understand. So tau, how do we find tau? Yes. So tau is equal to RC. And please do that before you start the experiment to have an idea how long you should be waiting. So if you do R times C and you end up with 10 seconds, I believe it's stupid to wait 70 seconds. You know, knowing that tau is 10 seconds, you would know something is not functioning in your circuit. What about item 2? How? Okay, 63% or 37%, depending on charging or discharging. Can you think of a third method, or it's difficult for you? Basically, we do something. We draw the tangent at the beginning of the curve. It will hit the maximum asymptote, or whatever you call it, the maximum voltage, and this is how you can find tau. Okay, this method probably would be used in the course, I don't know. In the lab, we're gonna stick to the 63% and 37%, and we're gonna use this being our reference or the theoretical tau. So we're gonna have theoretical tau and experimental tau. So for item 3, I'm gonna simply write the tangent method, and probably you guys can discuss it in the course later. Yes, somebody was talking. Was it you, Anthony? Anyway, what I wanted you to see in those graphs, the 63% will help you find tau, but be careful, tau is in the x-axis. The 37% for the discharging, so this is charging and this is discharging, will help you find tau for the discharge. And here you can see a circuit. You can see a circuit. Probably I can zoom in and move it a bit. Yeah, these are 3 different circuits. You can see which one will give you a bigger tau, the blue, the red, or the black. I need your input. The black needs more time to reach the maximum value. So yes, tau for the black is bigger. And you can see here that RC is 0.2 seconds basically. So it takes more time. And this is RC 0.05 seconds, so it takes less time, okay? So probably if the circuit is switching on and off at A and B, maybe probably the black circuit will not have enough time to be fully charged, okay? Anyway, we're not gonna do this. We simply need to measure using a voltmeter. Now, I need to show you both circuits. I hope this is gonna be informative, although you have it in the video. So this is a screenshot from the video. Let me explain what you have, and then I won't have to show you all of the video. You can watch it later. I will have to do that. I don't want to use any of the batteries. I'm using a power supply. Anybody can tell me what is the voltage across the power supply? Can you read it from the picture? Yeah. Yeah, this is 2.9. Originally, I wanted to hit 3 volts, but every time I put it on 3, it will go down to 2.9. So in this experiment, I took 2.9 to be the voltage of my battery. I call it a battery, but this is a power supply, and it's connected to these two terminals. Then I use the vacant springs. You have a wire, then a capacitor, then a resistor. The capacitor is in blue, the resistor is in yellow. So you have a series connection, battery, wire, capacitor, resistor. Then I take another voltmeter to connect it across the capacitor. I observe that the capacitor starts from 0 and increases, you know, the voltmeter will give you 0, and then the value increases slowly until it reaches 2.9. And this is charging. I use my stopwatch. You see my stopwatch, it gives you 6.19 seconds, so 2 decimals. In this case, 3 sig figs. Unless you go above 10, it will become 4 sig figs. I'm timing how much time it needs to go from 0 volts up to 63% of the 2.9. Very simple procedure to be done in the lab. And you will observe on the voltmeter that the voltmeter increases, like the value increases quickly at the beginning and then slow at the end. You see what I mean? You see the exponential. It's fast at the beginning and slow at the end. Then you will have to change your capacitor. So you remove capacitor 1, put capacitor 2 that is bigger in size. I mean, it has a bigger capacitance, and measure tau again. And change R1, R2, measure tau again, and check how tau actually changes as you vary C and tau. Eventually, they want you to use capacitor 1 and 2 in parallel on top of each other, capacitor 1 and C in series next to each other, and do the experiment again. So this is the charging. Probably I'm gonna write charging next to this one, just to keep that in mind. So charging, why is it in black? Charging, and let me make it in white or yellow or any color that would be visible. Yeah, charging, yeah. Now I want us to discuss the next picture, and I need somebody to speak up. What do you have in the circuit? Anyone? Just yes. Somebody to speak up. What do I have in my circuit? Fadil, can you unmute yourself? I would love to talk to you. Okay, Fadil. Unmuting yourself is impossible. Your mic is broken. You know, you can fix this by simply use your phone or tablet or some other device, you know? All right, let me ask you tiny questions, Fadil, and you can answer. I want you to tell me, what do I have in my circuit? So list the things you can find in the circuit. Okay, you have a C, you have an R, and you have a wire. Is it a closed circuit or open circuit? It's a closed circuit because it's closed with the wires. The voltmeter is connected across who? I'm sorry for making the others to wait, but Fadil is typing. So Fadil, you have to fix your mic. All right, so the voltmeter is connected across the capacitor because I want to observe the process of what's happening to the capacitor. You tell me, Fadil, is it a charging process or a discharging process? Can you guess? Discharging process, since I don't have a battery. Now, another question. Yes, no battery, thank you. The battery, it's still on, right? The power supply, is it connected to your circuit? Not at all. So I'm gonna grab a pen and tell you how I do the connection. I will actually use the red and blue terminal of the battery to connect on the capacitor just to make it fully charged, and count to 3, remove those wires, and start observing the discharge on my voltmeter. I definitely need a stopwatch, the same stopwatch, to be able to tell the time needed to go from maximum voltage, which is this one, down to 37%. Anybody knows what is 37% of 2.9? I need someone to calculate for me 37% of 2.9. So 2.9 times 0.37%. What's the answer? It is 1.073. I'm gonna say 1.07, okay, volts. I was hoping somebody was faster than me. So 1.07 volts. I have to look at my voltmeter. Yeah, so let me grab green. What's wrong with this? It's not taking. Anyway, so I'm gonna wait for my voltmeter to go down from 2.9 down to 1.07 volts. So you see 0.10, it means that the capacitor already passed the tau. Like now, I waited too long, and probably I'm on 4 taus or 3 taus, and probably I'm reaching zero very soon. So I'm not supposed to be waiting this much. I'm supposed to stop my stopwatch at 1.07 volts. All right. So here I'm gonna do all the combinations, like remove capacitor 1, put capacitor 2, then change resistor 1, put resistor 2, and do R1 with C1, R1 with C2, then R2 with C1, R2 with C2, and then have capacitor 1 and 2 in series, capacitors 1 and 2 in parallel, and you can see it on the video. I'm gonna give you all the results for tau and ask you to answer some questions, okay? A quick reminder for series and connection. I know you already know this. I'm not being able to move this. Well, am I? And how come I cannot click on it? All right, I can. So you can see which one is series, which one is parallel. Anybody would speak up, right and left? You guys are boring when you're muted. Just give me a reason why you want to be muted. What's happening? Do you have a party happening at your house? No offense, probably you have a party happening in your house. So don't be boring. Just a second, I have a problem not being able to remove the pen. Why? Okay, I can write it through the pen. So this is series or parallel? Quickly. Anyone? Series. I can't write. Ya Allah leh. So probably due to the recording, I want to type or insert or do anything. I can't. Okay. Anyway, this is a series connection, obviously, and this is how you find C total in case you guys need a quick reminder. And this is the parallel connection. You simply add the C. Yes, thank you, Chris. So series for the first and parallel for the second one. Because and then for you to find tau of the circuit, you don't use C1, you don't use C2, you use C total. In other words, you will have tau total. Tau total, you can compare it with tau 1 and tau 2 later on, okay? The video, this is the video. It shows you, I'm not gonna make you watch it because I know you need to watch it anyway later on. I'm showing you how I was doing the connections and how I actually observe the voltage going, charging and discharging, and how to put the capacitors. Like here, I'm plugging 2 capacitors in parallel. Yeah, probably. So, and how I do the series connection. Probably move a bit and see how the lab report looks like before I leave you. Some students are texting me on WhatsApp. This is the lab annual. Let's navigate quickly to lab 5. On the doc, I can simply click that. Okay. On lab 5, yeah. Okay, so this is lab 5. I want to see the lab report to show you and for you to have an idea. Okay, charge and discharge, simple explanation, very basic stuff. I will minimize a bit. Okay, so you have some fill in the blanks, possible answers. Here I want you to check the behavior of the voltage. So you can simply draw charge, discharge. Please, you don't need to show the points. This is not a plot, but give at least 2 values. Probably U max, take it from the video. And probably one of the taus, take it from the video, okay? Or at least the time needed to do all the discharge. So 2 points are enough. Now the table of results I'm gonna give you, this is tau for the charging, tau for the discharging. I ask you to find tau average because we believe tau charging and tau discharge should be the same, but they will not be the same due to the sources of errors, different sources of errors because different circuits. So you can find tau average to get your own tau. Here for the series connection and parallel connection, I'll be using 100K resistor. They ask you how The increase will affect the tau, and you have to use data to explain. Please don't say linear or proportional unless you prove it. Some questions related to the values, very simple questions. No linear regression needed, no RMS needed. It's simple physics, but please do it well, okay? And very short lab report. And now that you can do teamwork, and if you believe you don't need teamwork for this very tiny lab report, you don't have to work in pairs, okay? Working in pairs is only beneficial for me. Keep that in mind. It's not beneficial for you. And I don't want myself to take any benefit from this. So a very tiny lab report, some questions, you want to discuss it with your partner, go ahead. Do it yourself. It's good for you, all right? But it's up to you since you still have the option to work in pairs. I'm done for today. Do you have any questions? Okay, Ryan said no, honestly. Okay, Ryan, enjoy your day. Thank you, Chris. Bye for now. Thank you, Fadil. Enjoy your day, Joe. So I'm gonna go back to you, Joe. Everyone else, thank you so much. Have a nice day.